So simplifying algebraic expressions, section 1.4. First thing we're going to talk about today is writing algebraic expressions. All right? A lot of times, math kind of has its own language. Okay, and you think about in school, we in here speak English. You can learn Spanish, you can learn French, all those different languages, right? Well, math kind of has its own language. As in, you have to be able to identify some key words to know what type of operations they mean. All right? So, for instance, here, the first one says the distance remaining for a runner after m miles of a 26.2 mile marathon. A lot of times students see this and they start struggling. They're like, I don't even know. There's letters going on. There's numbers. We're struggling. I tell students, put a number in there. Have it make sense to you. Okay? M miles doesn't make sense to anybody, does it? But if I were to say, hey, you traveled 10 miles, could you tell me how many you had remaining then? Yeah, that makes sense. So whenever you're doing something like this, throw a number in there first. See what makes sense. And then go back to write your expression. So for instance, let's say I had 10. Let's say I went 10 miles here. Well, how many would I have remaining then, Crump?
16.2.
Yeah, I'd have 16.2. What'd you do to get that? We subtracted, right? Okay, now I'm going to go back here. Now, let's say we have m miles. I've traveled m miles. Well, what's the expression going to be with m miles? Same thing here. What would you say? So I would say 26.2 minus m. That's my expression. That's my answer. Okay? A lot of times it's easier. Get out of the variable. Put a number in there. What makes sense? What's logical about the problem? Then when it makes sense to you, pull the number back out, put the letter in. Okay, next one here. Number 2. The number of hours it takes to fly 1,800 miles at an average rate of n miles per hour. Looking at this, we got speed, we're traveling now. Okay, what do I say to do? Get out of variables into letter or numbers. Let's say I travel 100 miles per hour. If I'm flying, right, 100 miles per hour, would that make sense? I don't know, that's probably good speed, right? I don't know. It's been a while since I've flown. I like it because it's easy numbers. If I say I travel 100 miles per hour, how many hours would it take me to travel there? 18, right? Does that make sense to people? Okay, so I'd say 18 hours. Great. All right. Now I'm looking at the expression. I'm traveling 1,800 miles, n miles per hour. What would my expression be, Drew? Divided by n. 1,800 divided by n. Again, get out of the letters, put a number in. See what makes sense to you. Next one. Lucy's age Y years after her 18th birthday. Kyle, let's say it's 5 years after her 18th birthday. How old is she? She's 23, right? Makes sense. Okay. Now she's Y years after her 18th birthday. How old is she? 18 plus Y. Nice job, sir. Again, when you're doing these problems, throw a number in there. Yes, sir.
What job requires you to know this?
All right, next here. Try these 3 on your own. So writing algebraic expressions. Try these 3 on your own. The number of seconds in 8 hours. The number of apples in a basket of 12 after n more are added. And the number of days it will take to walk 100 miles if you walk m miles per day. Take a couple seconds to try these 3. All right, O'Connor, number 4. The number of seconds in 8 hours. How would you express that as an expression, Jake?
3,600
Yeah, 3,600 times h. Recognize, again, we're talking about seconds. So there are 60 minutes in an hour, and there are 60 seconds in a minute. So we have to take 60 times 60, and that's where we get 3,600. Okay? 5, the number of apples in a basket of 12 after n more are added. Jace, what do you say there, bud? 12 plus n, good work. All right, 6, the number of days it will take to walk 100 miles if you walk m miles per day. Jake King, what do you say there? Yeah, 100 divided by m. Did you put a number in there first to think about it? You just had it. Yeah, sometimes you got to think about it like, well, let's say I travel 10 miles per day. Well, if I travel 10 miles per day, how many days will it take me to get to 100 miles? 10 days, right? 100 divided by 10?
Yeah.
So that's where I get 100 divided by m. Next thing we're going to talk about today is evaluating algebraic expressions. To evaluate an algebraic expression, you substitute numbers for variables, then follow the order of operations. Most people remember the order of operations by the sentence, "Please excuse my dear Aunt Sally," which means parentheses, exponents, multiply, divide, add, subtract. Why did I group these in parentheses here? Who can tell me? Because you can do either or first. Do I always do multiplication before division? No, I do them in whatever order comes left to right. Same is true as for addition, subtraction. I always do them from which way, Drew? Left to right. Okay? So that's how we do the order of operations. Alright, we're also going to be evaluating. When I evaluate, for instance, like x equals 4 or y equals 6, that means I'm going to substitute those values in place of. So I have x's and I have y's. I need to substitute those values in and then use order of operations to solve. So let's try number 7 here. I want to evaluate each expression for x equals 8, y equals -5, and z equals 4. X equals 8, y equals -5, z equals 4. I'm going to plug them in. So I'm going to plug 8 in for x. So I have 8 plus 3 times 8. Notice when I plug them in here, I put parentheses. Why am I putting parentheses there? To show that I need to do what operation probably? I need to multiply. -2 times 4. So I plug them in. Now I need to do order of operations. So I would say 8 plus. Would I want to do 3 times 8 there, or would I want to do 8 times -5 first? Anybody? I prefer to do 8 times -5. Why? Because it's easier to multiply. Okay, if I do 8 times 5, what's 8 times 5? 40. -40, right? It's easier to multiply -40 by 3 than it is to do 3 times 8, 24, or 24 times 5. Okay, remember, that's those properties we talked about the last couple of days. I can switch those properties around and multiply them instead of the same answer. So 3 times 8 times -5 is really negative, what is it? -120, so -120. And then 2 times 4 is 8. So I have 8 minus 120 minus 8. My answer here would be what, Drew? Great, -120.
Wait, how do you? Oh, because it cancels.
Oh, yeah.
The 8 and the 8's cancel out.
Yeah.
Yep.
So I had that.
And then I have 8, xyz minus x squared. So I plug 8, -5, 4, minus 8 squared. Again, recognize, plugged in with parentheses. On number 8, could I do 8 times -5 first or -5 times 4 first? Does it matter which way I go there first? Probably not. Would I want to do 8 times 4 first? No, that'd make it tougher, right? So think about that. So 8 times -5 times 4 gets me...
Oh, it'd be -40.
-40 times 4 is -160.
Yeah.
Minus 8 squared is 64. So I have -160 minus 64, which gets me an answer of -224. Nine, x squared y minus y squared z. So I'm going to plug it in with parentheses here. I have 8 squared y minus y squared z. Order of operations says I need to do what here, Jake O'Connor? So what's 8 squared? So I have 64 times -5. Minus, what's -5 squared, Jake? Minus 25 times 4. Now I can do my multiplication, correct, Jake? What's 64 times -5, Jake? So it's -320. Minus 100. -320 minus 100, Jake? That'd be -420. Nice job, sir. That is correct. Again, order of operations. Plug them each in separately, and then complete it with order of operations. Try these next two when it comes up here shortly.
When we get our iPads, will we be able to like see your notes? And so when we go home and finish our we can go over the notes.
Take a couple seconds to try these two on your own. All right, number 10. Miss Foster, what did you have for answer number 10?
A negative 19.
It's negative 19. You did the same thing here. Now let's pay attention here. Watch. So I plug it in here. I get 5 squared plus 4 times 5 times negative 2 minus negative 2 squared. Recognize, I put the negative 2 in parentheses on the end there. Okay, now I've evaluated here. So I have 25 minus 40 minus 4. Okay, it's minus 4 because it's negative 2 squared. Negative 2 times negative 2 is a positive 2. I still have subtraction in front. Okay, now 25 minus 40 minus 4. Left to right. 25 minus 40 is negative 15. So I get negative 15 minus 4. They're both negatives, right? Negative 15 minus 4 gets me then negative 19. Okay, so I get negative 19 there. 11. Jake O'Connor, what did I get? I believe that's correct. Is it positive or negative 12 though? Huh? Ooh, let's work it out here. So I have 2 times 5 minus 5 times negative 2 plus 4 times negative 2, right?
Oh, so you have the 5 in parentheses.
The negative 5? So let's work it out here. So I have 2 times 5, so I have 10.
Up top it says x is positive 5, so I put it in parentheses.
Yeah.
Wait, what's the answer?
Even if you put parentheses here, that's fine.
Yeah, but then I went 2 times 5, which you have is 10, minus 5 times 2, which is negative 10, so it's minus 10.
So it'd be minus a negative 10, right?
Yeah.
Which 2 negatives give me a?
Positive, that's right.
So I have 10 plus 10.
Oh.
Okay, so that's where I went wrong, and you have minus.
Minus 8.
Okay.
10 plus 10 is 20. Minus 8, I get a positive 12. Nice job, Beast. All right, and again, yeah, recognize the positive negatives where a lot of students make mistakes with the evaluating. There's always something with positive negatives. All right? Last thing we're going to do today is we're going to talk about combining like terms. We talked about this yesterday a little bit with respect to radicals. In order to combine like terms, you have to have the same variable as well as the same exponent. So for example, can I combine 3x plus 4x squared? Can I combine those two? No, not the same variable. Could I combine 3x and 4x? Yeah. Could I combine 3x and 4y? No. Could I combine, let's try this one. Could I combine 3x plus 4xy? No. I have to have the same variable, same exponents. The first one has just an x, the second one has an xy. So the second one has different variables. So I cannot combine those. So let's look at number 12 here. I'm going to simplify it. 12x plus 30x. Chow, what's 12x plus 30x? What do you got? You are quick on that one. You're like, yes. 42x. 13. 4n plus 4n squared plus 3n. Bennis. 7n plus 4n squared is correct. Good work, sir. 14. 16y plus 84y. Rob, what do you got, buddy?
For 14?
Yep. That'd be 100y. Good work, sir. Take a couple seconds to try these through on your own. Same idea. Combining like terms. Hannah, what do you say on 15? What's 12x plus 5x plus 3x? 20x. Nice job, Hannah. 16. X squared plus 5x plus 2y plus 7x squared. Kyle, what'd you get there? Good work, sir. And 17. Daniels, what'd you get here?
We got 4w squared.
4w squared. Nice job. Last thing we're going to talk about here is what happens if I have parentheses. What's the key if I have a number in front of parentheses? I need to distribute. And the key of distributing is you need to do it to both terms. So this would make it 2x minus 8 plus 9x plus 1. So 2x minus 8 plus 9x plus 1. Now I can combine like terms. Okay, so what's 2x plus 9x going to get me? 11x. What's negative 8 plus 1 going to get me? So 11x minus 7 would be my answer.
So why do you add the 2x and the 9x?
Why do I add them?
Because the 8 becomes the negative, correct?
Because the 8's a negative. You take the term in front. Yep. So this is a positive 2x because there's no operation. And this is a positive 9x, so that's where you add it. Yep, good question. 19. 3k minus 8 parentheses k plus 2. What's something you have to remember to do on a problem like number 19? Distribute the what?
8.
You have to take the negative along with it. A lot of times students remember to take it to the first one. They forget the negative to the second one. Okay, if there's subtraction, that means negative. You have to take the negative. That would make this problem 3k minus 8k minus 16. Notice the difference. You have to take that negative across. So it'd be just negative 5k minus 16. Recognize that. 20. What am I distributing on 20, Katie? A negative what? I'm distributing a negative 1. So that makes that 4a minus 4a plus 3, which gets me an answer of what, Katie? 3. Good work. Yeah. Hang on a sec. All right, try this one on your own. It says find the perimeter. What does perimeter mean? Yeah, perimeter means the distance around. So that means I were to add up all of the sides of this figure. So take a couple seconds and find the perimeter on your own. All right, let's look at this. Jake King, what'd you get for an answer?
2a plus 3b.
Ooh, not 3b, but 2a plus 4b. What do you guys probably forgot the little one up there? Yep. So if I add them all up, yeah, I recognize. What do I get when I add 2 halves? 2 halves get me a whole. So I have 1a plus another a gets me 2a. 2b plus b gets me 4b. 2a plus 4b would be my expression there. Here's your assignment.